Smari, welcome to the second of the Global Swadeshi Dialogs. Tell me who you are.
Well, I'm born in Iceland. I'm half Irish. I spent the first decade of my life living in England.
I'm
And
sorry.
after, what?
I'm
Oh,
sorry.
yeah, it's terrible, isn't it? But after that, I moved to Iceland and onto this cluster of volcanic islands out in the middle of the North Atlantic Ocean. And I've been here on and off ever since.
So you're some
So,
kind of seasteader, only it started kind of 1,000 years ago.
yeah, well, I think the oldest part of this island is about 17,000 years old. So, yeah, but we've been growing it for a while.
Yeah.
We had this eruption on this island in 1973 that crushed about 3,000 houses and kind of messed things up a bit.
How
So,
when was the Westman Islands settled?
it was settled around 1870. No, 870.
870. Okay.
Yeah,
So you've had settlement there for about 1,200 years,
yeah.
and it's about 5,000 people. Is that right?
Yeah, roughly.
Okay. And it's a little stone dot in the middle of the North Atlantic. How far from the Icelandic coast?
We're about 4 miles from the coast, but it takes about 3 hours by boat to get to the nearest harbour.
Gotcha. So it's really, I mean, it's not quite the ends of the earth, but it's pretty close.
Yeah. It's definitely one of the corners of the world.
Yes. Excellent. So anyway, so you're in the Westman Islands right now.
Yes.
Tell me what it is that you're doing.
Okay, so I'm currently working for the Icelandic Innovation Centre, trying to set up the first Icelandic Fablab. And I've been working on this for about a year. I got pulled into it, kicking and screaming about a year ago. It's funny, actually, how that happened was I had seen the TED Talk where Neil Gershenfeld is doing his explanation of what Fab Labs are. And I kind of watched it and ignored it for a couple of months. Then about almost exactly a year ago today, I suddenly remembered it, and I was sitting in an office just a couple of rooms away from here, and I thought, hang on, this might actually be a good idea. So I Googled it, I tried to find out what I could, found this email address, fired off an email saying just, hey, who are you, what are you doing, tell me more. 15 minutes later, I get this boilerplate wall of text describing the project, and at the bottom of it, there's this footnote saying, oh, by the way, we're having this conference in Norway on Tuesday. Do you want to come? And this is on a Friday, and I was going to do something insane anyway, so I bought a ticket, and that's kind of how I got involved with the Fab Lab project.
Yes.
After that, I went into the entire convincing people and raising funds gig, and a couple of trips to the States, and now we're almost ready to set things up. We're just sitting around waiting for the equipment to arrive, actually.
Wow. So you have the space, you've got an established area, you're going to put the Fab Lab, all that stuff is ready to go.
Well, we don't actually have the space yet. We're hoping that'll come through tomorrow.
Okay. So you're right in the middle of, you have the funding and you're just getting everything organised to put little boxes on the ground.
Exactly. It's actually it's in a mess at the moment, but that's the way it should be. It's fun that way.
Well, I mean, that's the way these things are when you're starting from scratch in such a short time.
Exactly. So, yeah.
So, what is a Fab Lab?
Well, it started off as this project in MIT where they thought, okay, we've got all this big government grant, but that means we have to do outreach. So they bought $50,000 worth of equipment and stuffed it into inner city Boston, where anybody could come and use the equipment. And it kind of exploded from there. The idea is make a laboratory where anybody can make anything. And it's like the prelude to molecular assembly in the home, where you'll have the Star Trek replicator or Stevensonian nanite, where you can build your own island and go seasetting on it, or just whatever sort of assembly you wish. So this is like in the middle. It's the bootstrapping phase.
So, I mean, let me put this into context. You've got $50,000 worth of tools, and that's little laser cutters and little robotic machine tools and things for casting plastics and things for making little circuit boards and electronic components and solderers. And I mean, I'm missing anything major there?
No, that's about it.
Okay.
All the equipment is, as far as we can, it's computer controlled.
Okay.
That being the innovation here. I mean, computer controlled CNC devices have been around since the 70s, but what's changed is now we can suddenly afford to put one in every town, every 4,000 person town in the world.
Yes.
And that's what's cool about this.
Yes.
So, and soon every school will be able to afford a Fablab, and making things for a one-man market will suddenly be possible and plausible.
So this is sort of like 21st century shop class, where you have a bunch of these serious machines that can make serious things. And I mean, we're talking about, you could go in here and you could basically build a transistor radio complete with the cool little waterproof plastic case and the knobs and all the rest of that.
Yeah.
That's sort of the level of complexity on that side of it.
Well, you can actually go one up on that and just build your own computer from scratch. I mean, it won't be a powerful Pentium-style machine, but it will do everything a computer is expected to do.
Yes.
There's plans to do environmental measurements, like doing humidity and temperature studies, networked devices for that.
Yes.
And the idea is you've got this Fablab network with 35 labs spread all over the world at the moment.
Oh, wait a minute, hang on. So there are 35 of these things?
35 is a rough estimate, and it's the closest to the real figure that I've been able to find.
Okay, and they're sort of dotted around... I mean, they're mostly in America. Where are they? Yeah,
there's 4 in South Africa. There's 1 in Ghana. There's 2 in Kenya, and then there's Boston, Chicago, San Diego. You've got all the usual suspects in there. You've even got 1 in Tokyo.
Wow.
There's 1 at the top of Norway, just at the northernmost part of Norway. There's 1 in rural India, and. Wow. They're setting up 1 in Afghanistan at the moment, in Jalalabad.
Oh, that's Dave Warner's thing, right?
Yes, Dave Warner, exactly.
Yeah.
And they're popping up all over the place.
Okay. So these little shops are all kind of much alike, right? It's the same roughly standard set of equipment in each shop? So they've all got roughly the same capability to make objects?
Yes, and to a very large degree, the same equipment.
Okay.
There's been some change out, some replacements, but for the most part, it's every lab should be equivalent.
Okay, so theoretically, if you design something that can be manufactured in the Icelandic fab, you can send those designs across the the fab in Cape Town or Soweto, and they can run off essentially the same object. Yes,
and actually, we've got a Fablab-wide Git repository for designs.
Oh, that's interesting.
Yes.
Now, is that a recent thing?
No, it's been going on for at least a year.
Okay, so it's a distributed version control system for sets of plans which have been tested and can be made inside of a fab. And I mean, roughly how many things are in that repository?
Not that many. Unfortunately, there hasn't been that much useful stuff, but there are a few gems in amongst the empty folders. Stuff like a thinner client, which is a very small computer that you hook up to a television.
I saw pictures of these. They're like $10 or something like this, and
or even cheaper.
Wow.
Yeah, I think you should be able to do it for $5, but don't quote me on that.
Okay, but hang on a second. So you plug this thing into a computer, and into a television,
Yeah.
and it generates the appropriate signals to display like text on the screen.
Yeah.
Okay.
And it's just a text console, and it's like one of the old teletype terminals.
Okay, so it's like a dumb terminal for $5 that you plug into a TV set.
Yeah, and
Well,
that's great if you have a network.
Well, sure, but that in itself is really pretty significant.
Yeah. Then there's other things like.
I'm just imagining that, a room full of those connected to like a Bluetooth hub that was, hanging off a telephone, acting as a relay to some cell tower or something. I mean, that right there is the kind of computing that you could do almost anywhere on Earth.
Rural mesh networks are definitely the thing of the future, and that. And carpeting entire towns with wireless network is one of the things I'm very interested in.
Yeah.
There's been a lot of work been done in the Fablabs over the last year on designing antennas.
Interesting.
Making high gain, durable antennas out of glass and tinfoil.
Wow. Excellent. Well, anything involving glass and tinfoil.
Yeah, that's your specialty, isn't it?
Oh, absolutely. Well, in Afghanistan, they've been talking about having a solar cooker design competition. Where you can use the laser cutters on cardboard to produce precisely the shape that you want, and then cover the thing with tinfoil and then cook in it.
Yeah.
And you can do all manner of parabolics and non-imaging optics and all this kind of stuff. You can cut plastic and glass for enclosures to hold the heat. And there's all kinds of really amazing stuff that you can do if you've got the ability to take plans and just print them off on a device.
Yeah. So Fablab's on the lowest level. You've got it used for innovation and seed companies, startups that want to take some design and manufacture it. And that in Cape Town, there's lots and lots of really good stuff going on with clothing designers and textiles manufacturing.
You could cut that stuff on the fab machines as well?
Yes, exactly.
Wow.
And wearable electronics are actually coming in strong. But
wow. From Cape Town?
Or
just in general on the network?
In general.
Wow.
I mean, when I was in Chicago last August, there was talk about making a vest for biking that had like a stop sign on the back. That so if cars came within 10 meters of you, it would start blinking a stop sign with LEDs on your back.
Wow! So you'd actually have a detector that would point backwards, and it would be
and it's very simple to make, and it's a couple of hours worth of effort, and then you've got a great safety device. And then if we move up one level past the novelty items, we've got important stuff like instrumentation for rural areas. In India, there's been a lot of work put into one of the problems they have there is when buying milk in the market, you never really know if the milk has been watered down or not.
Yes.
So the cream content of the milk is something that people want to measure. Simple instrumentation for that has been made in the Fablab. So basically you stick two wires into the milk and it'll give you a readout saying how much cream is in the milk.
Wow.
So that way you can gauge the pricing. And that kind of thing can lead to health benefits or whatnot. Moving even farther up, you can do hardcore science with this. And there we come into the entire environmental measuring system that I mentioned earlier. And a spin-off from that I've been considering is here in the Western Islands we have the biggest puffin colony in the world. It's about 4 million puffins.
That's a lot of puffins.
Yeah, it's quite a big colony.
Yeah,
but
I expect it's gotten a little bigger since people stopped eating them regularly.
Oh no, we still eat them.
Really?
And
man, puffin tastes bad.
No, puffin tastes good.
I guess you evolved to like the taste of puffin. I think you must have evolved to like the taste of puffin. The one time I had it, oh man.
Where did you have it?
Someplace in Reykjavik.
Oh, yeah, see, people in Reykjavik don't know what to do with puffins. They don't know which way they turn.
So there are special puffin recipes of the Westman Highlands, huh?
Well, generally, you want to smoke the puffin and serve it with mustard.
Okay, I'll give that a try when I get out there.
Just take my word for it. But okay,
Anyway.
So one of the things is the puffin colony has been going. It's been rapidly decreasing, and since it's 4 million puffins, and we only hunt about less than 100,000 a year.
Yes.
You know, it's hard to say that hunting is the main reason for this.
Sure.
So it's probably global warming or something related.
Some kind of general environmental effect.
Yeah. And their main feedstock is a type of fish that's not really found in copious quantities around the islands anymore.
Mm-hmm.
So one of the things I've been considering is using the Fablab to construct some sort of measurement devices to put in the puffin holes to measure humidity and comings and goings of the puffins.
Yes.
So that's something I've been trying to organize, but until I get the lab set up here, I can't actually move forward with that.
So, I mean, this is very interesting. What you're talking about here is the Fablab as an enabling technology for other projects.
Mm-hmm.
That you get into a situation where, it'd be great if I had a device that did X, Y, Z, and then you figure out roughly how to make it, knowing the capabilities of the lab. So you design to the capabilities of the fabrication technology you have, and then you turn out specifically the tool for the problem that you have.
Exactly.
I mean, what it gives me this image of is like, they talk about, utility trees where you have this kind of, fractal, manipulator.
Yeah.
That it's this thing of like industrial production produces these great big metal slabs, and the Fab Lab produces like this kind of adaptive tentacle that gets right down into your problem and solves exactly what you need to do. That It's a way of like pushing technology into the nooks and crannies of the problem.
Yeah, and you can think of it as a whole new tech tree, really. I mean, like if you take Marchin's Open Farm Tech and you add a Fab Lab into that, then suddenly you have this this sort of set of technologies that first off do empowerment, which is always the first thing when you get a new technology. Then you have to educate the people around the technology. Then you start to build solutions to problems, and then you start getting markets.
Yes.
So, and of course, the market thing is something that a lot of people reel back in horror when they hear that. But it's actually an interesting facet of the entire thing, because once you have Fab Labs everywhere, the market is no longer centralized manufacturing and then you have global delivery, but rather you have centralized, to some extent, design.
Yes.
Then you ship the designs all over the place, and they get manufactured locally to whatever quantity is required.
So this is the sort of idea that your Nike, produces a sort of shoe template that you then ship out to the Fab Lab locally that will run you off a shoe configured to your foot from that basic sort of parameterized model.
Exactly. And if Nike wants a business model after 20 years, what they're going to have to do is stop selling shoes and start selling shoe designs that people can just print out in their homes.
Interesting. So, I mean, there's an implicit assumption here that in the same way that computers went from being, what's the name of the West Coast Computer Club where Jobs and Wozniak started? Homebrew, right? So you had Homebrew Computer Club where people made their own computers, and from that came the personal computer revolution. It sounds like what you're talking about is the anticipation of a similar phenomena for fabs.
Yeah, or rather, the Industrial Revolution got it half right. We're fixing what they got wrong.
Tell me more about that.
No, okay. Industry was never intended to be owned by huge conglomerates.
Okay.
What it was the first people who were introducing industry were people like Thomas Newcomen, in the 1790s with, or actually no, early 1700s with the machine for raising water with fire, which was intended to pump water out of mine shafts.
Yes.
So it was the first steam engine. From there on, you have all sorts of minor breakthroughs leading up to the Industrial Revolution.
Yes.
And then suddenly, it's like the switch was flipped. And suddenly it wasn't just people, individuals building steam engines to solve problems, but rather it was people with lots and lots of money buying a whole set of steam engines and then using them to try and centralize the entire workforce.
Yes.
So what we're doing now is we're taking that back. We're decentralizing the workforce.
Decentralized industry.
Yeah, putting industry into the hands of the people, because that's where technology always belongs.
Interesting. So, desktop publishing, right, was an example of something where this already happened.
Yeah.
You got the laser printer, and rather than having $50,000 worth of Letraset kicking around, you walked in with your, RageMaker file and you printed off whatever it was, and there was your camera-ready originals.
Yeah.
Similarly, laser printers initially were about $10,000, and now I think they've come down to about $120,000.
You know the story of how the bubble jet came into being?
No, I don't.
Okay, well, the thing is, laser printers were invented long before the bubble jet.
Yes.
But laser printers were expensive. And then there was somebody who said, hey, hang on, bubble jets could be neat. They could work. Designed a bubble jet. And I can't remember which company it was, but whoever owned the design or the innovation there, they said, wait, who would ever want a bubble jet? It's crappy quality. The ink smears. Count up all the faults of bubble jet ink technology, and nobody wants it. But they failed to factor in the small thing of price. The reason bubble jets got popular was because they were extremely cheap, and they were good enough.
Yes.
Yeah,
Absolutely.
So,
I mean, the worse is better thing is a pretty reliable rule. Yes.
Yeah. Okay. So the exact same thing. You have multi-million-dollar 3D printers today that aren't actually all that good. And then you've got Adrian Bowen's RepRap, which it's not fancy, it's not interesting for big companies, but it's good enough for home use.
So, just for context, tell me what the RepRap is.
Okay, the RepRap is a British design, British idea, and Adrian Bowens, who's working on that, he set off with the goal of building a machine that can be volume and bootstrap. That is to say, build a machine that is fully capable of self-replication.
Okay. And this thing is basically a 3D printer, right? You put goop into it, and it makes shapes in the goop.
Yeah.
And then you click the shapes together and add some other electronics, and it makes another one of these things which prints goop.
Exactly.
Right.
And you can make anything with it. You can, within the realm of what you can make by additive plastic placement. But the interesting thing about RepRap is that I just heard about it today. They have managed self-replication. It still needs some assembly, but they have managed to replicate a RepRap. So
it's a printer that prints printers.
Yes, exactly. And and after they printed out the first copy, they made the copy, the child, generate a grandchild.
Wow.
So now, if you just put that into context, exponential growth here, say each printer only prints out 2 copies of itself.
Oh.
Then you have 2 to the power of n. That means after 10 iterations, you've got 1,024 of these devices.
Wow. Wow. So what we're talking about is like LAN parties where people bring their printers and print off more printers, and everybody goes home with an additional printer. Like all the people who came without a printer leave with a printer.
Yeah, and all you need is goop.
Yes. We must beware the patented goop barons.
Yeah, exactly. And of course, this is going to lead to a lot of grey goo once you get nanotech sorted out.
Well, I'm still...
Let's not worry about that just yet.
I was going to say, I'm still skeptical about the thermodynamics of nanotech, but... I mean, this is a pretty historic thing, right? Having a machine with which you can make copies of the machine. This is what Martin was talking about last week. Exactly. This idea that you've got a set of machine tools which can be applied to raw stock to produce more copies of those machine tools.
Yes, and the RefRap is a very unfancy version of this, but it works. That's the first step.
And and it's a big deal because it's like £300 or something. What's that? $400, £300?
Yeah, something like that.
Yeah,
$400 for a machine that is capable of breaking the volume barrier, which is that once you've broken that barrier, you can essentially make anything.
Now, when you say volume barrier, you're talking about the price per unit for a small batch rather than a big batch of an object.
No, the theoretical barrier of what you can create, what you can make.
Oh, okay. Sorry, explain, please.
So making things always requires tools, right? So you get a tool that you get a spanner, and you can make anything that requires only a spanner to make.
Yes.
So if you get a tool that is capable of creating a perfect copy of itself, then that tool is capable of creating, where's the limit? That was one of the big questions that was laid forth in the 1950s, and nobody's been able to answer yet.
Right.
And, what's amazing is, as the more insane the idea, the easier it is to make.
Go on.
No, I'm going to let you extrapolate on that.
Well, I mean, in general, this comes from whole systems thinking, right? That it's much easier to get a large performance jump in a system than a small one. Because for the small performance jump, you take lots of little improvements, and for the big performance jump, you sit down and say, okay, what are we actually trying to do here? And then you find the simplest way of doing it.
And, okay. Let's try attacking this from a different angle for a moment.
Yes.
Okay, what does this mean for personal freedoms?
No. Well, the ability to print my own shoes doesn't obviously immediately turn into more freedom.
Yes, exactly. The reason this is an interesting question is because in the 1980s, Richard Stallman asked, okay, why should people not have the ability to edit their own software?
Yes.
Fix software.
Yes.
Okay, the same applies. Why should I not be able to grow my own house?
Okay. So your VCR comes with some dumb set of restrictions that won't let you record what you want to record.
Yeah.
So you build another one that doesn't have those restrictions.
Mm-hmm. Or, even better, you decide that you want your VCR to also be a telephone. You add that functionality.
Right. So what we're talking about here is taking the commercial bottleneck away from hardware development.
Yes.
So I can finally get my little device that has an actual usable keyboard, but otherwise almost no computing power.
Yeah.
Like I want one, I build it. If you want one, I give you the plans, you build it.
Make your own. Or even better, go find some free hardware that somebody else has designed, and download it and tailor it to your own needs.
So sort of cobbling together cobbling together consumer goods in the same way that we cobble together software.
Exactly.
You get a library, and it's the digital television library, and you plug that into your device, and now you've got a surfboard that watches digital television.
Yes.
Okay.
And of course, it's only a matter of time until somebody comes up with mashups for What is the Facebook of physical objects?
Oh. Okay.
So I think
Wow.
with regard to
Wow.
digital freedom, I say digital freedom. This is a term that I use a lot, meaning freedom applied to technology or anything that can be digitized.
So not freedom to show people the digit if you don't like what they're telling you to do.
Well, no, because freedom to or
Foundation for digital freedom, yes.
Yes.
So what we're talking about here is the scope of things that you're allowed to make, right?
Yeah.
When you say digital freedom, here's a file, it contains an object. If you produce this object, is the object legal or illegal?
Yeah. And why not make everything open and free so that everybody can just download and modify and remix their designs and
So we really are in sort of free as in freedom territory here.
Yes, definitely, because the entire goal of the Fablab project it came out of this lab called the Center for Bits and Atoms.
Mm-hmm.
The mandate, which is to bridge the gap between bits and atoms.
Yes.
And it makes sense. Why should digital reality be somehow different fundamentally from physical reality?
So free speech expressed as objects.
Yeah, why not?
You speak into a file, then you run the file and its software, or you fab the file and its hardware.
Exactly.
Oh Lord, this is going to get interesting, isn't it?
Oh yeah, and we haven't even gone into the entire, what happens when you start looking at the universe as a computer? What can it compute?
Yeah. So
the thing is, in this entire digital fabrication context, there's so much ground to cover, and so much of it is still within the realm of the impossible that, coherent discourse is almost impossible.
Right. And the whole thing has this kind of extropian shriek at the end of it. Wah!
Yeah, exactly. And, the best you can do is try and, lay it out in simple terms, point at good projects that have given good results, and, that's stuff like the RepRap and stuff like the textiles stuff in Cape Town.
Yes.
And you just keep pointing at that kind of stuff, and eventually you just hope that people will figure it out.
Right. So so you're talking about the small, simple, easy to understand stuff now, and pay no attention to David Dalrymple and what he's working on with this conformal computing business.
Exactly. Yes. Precisely.
Right. Pay no attention to Mr. Dalrymple.
Yeah. No.
Who did you
it's all part of the show. There's nothing to see here.
Right. So just the bust David on this. He's working on computers that you measure by volume. So you get 3 pints of a computer, and it's 5 times more powerful than a sixth of a pint.
Yes.
So it's computer goo that self-organizes to do your computations based on volume.
Exactly. Well, not necessarily based on volume, but one of the core concepts in this, as far as I understand it, is using cellular automata for distributed atomic scale computing.
Okay. Wait. So molecular scale connection machines.
What?
Like a molecular scale connection machine.
Yes.
So vast kind of bit plane processing with simple molecular steps.
Yeah, so think about, how can you calculate the exact value of pi using Lego bricks?
If you have a few 100 million Lego bricks, you can get pretty close. By drawing a circle and counting.
Yeah.
Yeah.
Or even better, what this essentially does, the stuff that David is working on, is it puts the entire programming thing, it takes it out of the text editor and puts it into the Paint program.
Okay, programmable matter.
Yes.
Yeah. Okay, so you have a bucket of goo, you take a piece of software, you drop the software on a chip, let's say, into the bucket of goo, and the bucket of goo grows into a sculpture that purifies the air around it.
Yeah.
I mean, straight down the line, implementation of nanoscale stuff, off in this direction.
Okay. The question here is, why is this important? And the answer is probably that if you look at how industry is done today, even in the Fab Labs, it's very brute force.
Sure.
You're using force to alter the atomic structure of things like metal.
Right,
and you
blow torches, hacksaws.
Yeah.
I mean, real macro scale, machine tool force.
Yeah, and you use brute force long enough on a sheet of metal, and you might end up with a ship. But it's brute force. It's not the most elegant way to do it. It's not even a very good way of using the resources you have. Because not only are you wasting precious material, all the waste from the process, you're also wasting a lot of energy.
Yes.
So
yeah, like beating a curve into a piece of metal it's an intensive process.
Yeah. So what we should be doing is not so much using the hammer to build the ship, but rather convince nature to build the ship for us. And that comes into the line of looking at nature as a computer and trying to get it to compute to generate the objects we need.
Okay, just whoa, let me break that down here. So, I'm reminded of Richard Feynman's story where he's got a house full of ants, and what he starts doing is laying sugar trails, or he starts moving the ants out of his house so they lay a trail away from the house rather than towards it, or something like this.
Yeah.
And after a while, all the ants are redirected around his house, and there's no problem.
And if Richard Feynman had been a computer scientist living today, instead of leaving the ants out of the house, he would have been, making logic gates with them.
So, wait a minute, you're a very bad man. Hang on a minute. So what you're talking about here, when you there's three steps here, right? The first is looking at nature as a computer. Yeah. The second is persuading nature to do the computations that we want, and the third is not going insane in the process. So.
Okay, I'll agree.
As an example of this, right, they did analog computers in the 50s where you had things like a bucket that had a shape of a parabola as the shape of the bucket. So as you poured liquid into it, it essentially computed the volume under the curve for that specific equation of bucket shape.
Yeah.
And they could chain these things together to do rapid computation in things like economic systems. You had a series of buckets and pipes that matched your theory about the economy, and then you poured liquid into various buckets and the system settled in equilibrium and it told you what the overall performance would be. Yeah. So you're talking about like that only without water and buckets.
Yes. You're still using the fundamental forces of nature, but you're using them in a much more precise way.
So now we're talking about things like molecular computing or tricking your E. coli into performing functions or things like this.
Yeah. Actually, DNA is a perfect example of that because we've been messing around with the E. coli for decades. It was the first genome that was mapped by humans, as far as I know. It's a very small genome. It's only about 1,000. You know the word I'm talking about.
Well, base pairs? Genes, okay. Yeah, 1,000 base pairs would be too small. Yeah, 1,000 genes.
It's 250,000 base pairs, give or take. So it's really small. And all life on Earth is based on 23 amino acids, which the DNA codes for. So you have the DNA coding for these 23 amino acids. They make proteins. The proteins fold up, and then you have a functionality.
Yes.
So one thing that Saul Griffith did a couple of years ago was he figured out a way to do the exact same thing as proteins are doing, except with magnets.
Oh, I think I saw a video of this.
Yeah.
Right? He had this long plasticky thing of magnets, and then there was a machine that shook them or something?
Yeah, or I think it was different colors coded for different colors of the shapes, or different colors had different magnets attached to them.
Yeah, that was it.
So that they would fold in a different way and make arbitrary shapes.
Yes.
And there's other people who've been working on the same thing. There's Hod Lipson has been doing lots of great stuff on that.
Okay. So what we're talking about here is there's currently a gap, right? You've got this kind of molecular level, DNA level game down here, and then you've got these self-replicating machine shops up here.
Yeah.
And what you're talking about is over a period of time, building a bridge from both sides to the point where you have kind of a self-replicating nanoscale machine shop.
Yes.
Where you say, bucket of goo, make me a shoe, and there's your shoe.
Exactly. And there's two different modes of attack from this. One is coming from the research side, where you're actually trying to do the nanoscale ingenuity.
Yes.
And the other is coming at it from the cultural side, where you're sticking a Fablab into a small town and, opening up the doors and saying, what are you going to do with it? This is done, from my point of view, for two reasons.
Yes.
One is to get people accustomed to the technology as it's arriving. Push out the newest technology as it arrives, and get all the interesting synergy effects from that.
Okay.
The other is to safeguard the freedom, which is to say, safeguard.
So I mean, the freedom that we're talking about here is essentially the freedom to perform magic, right?
Yes.
To take a bucket of stuff and turn it into the shoe that you want, as a fundamental freedom of action kind of a thing, right?
Yeah, because what happens in the current patent law environment if suddenly this molecular assembly technology comes into existence and there's this one company that patents it?
Sure. I mean, this happened with some basic things in computing, right?
Yeah.
I mean, public key cryptography was patented. Like the RSA algorithm was patented for a long time, and that was a huge issue.
Yeah, it was, and it you could say that it contributed to the lack of strong crypto amongst common people today. I mean, how many people
absolutely
knowingly use strong crypto?
I mean, the reason that strong crypto isn't built into all of our operating systems at a fundamental level is because it just wasn't legal to do that when the operating systems were being built.
Yeah, exactly.
Yeah.
So
no, I'd agree completely.
Yeah. So imagine if movable type printing had been patented. That would have slowed down the entire adoption process for movable type.
In fact, there's a bunch of history about this, right? The early printing presses were licensed and controlled by the Crown. And you could only print what the Crown said was okay to, and that was the foundation of copyright.
So there's always this, there's been control being put onto people for a long time. I mean, freedom of speech was severely impaired by the Catholic Church back in the days of the inquest or Spanish Inquisition and all that stuff.
Yeah.
And well, actually, they're still trying today, but not working. They don't have as much traction.
Ask the liberation theologists in South America, how effectively the Catholic Church can muzzle people.
Yeah.
I mean, it's not a small consideration that you had this unification of Christianity and essentially human rights-oriented socialism, and the Catholic Church came down on it with a sledgehammer.
So first they were controlling stuff.
Yes.
Then, there's always somebody trying to control stuff. Nowadays, it's the owners of patents.
Sure.
They are trying to rule the people of Earth with a very hard fist.
And I mean, this gets down to this partnership between capital and the state, right? That copyright and patent are essentially rights which primarily relate to capital. And then the state is in partnership with these entities. Like you see this in America, where all these large corporations own news outlets and use patent and use copyright particularly to form this kind of lock-on content.
Yeah.
Yeah.
The neoconservative libertarian wing of people who say, we should minimize the government. They want the government out of the way, except they still want the legislative wing to exist to make sure that their patents and their copyrights are, maintained well.
Sure. I mean, I wrote a short article on this a while ago about if you're going to get the government out of things like marriage, you should also get it out of the business of incorporating companies. And then if you run the numbers, the limited liability corporation is essentially a government subsidy in the form of free insurance to the shareholder.
Yeah, so you're basically marrying the shareholders to each other and saying instead of running a home, you should run a certain function.
Right, and why should the government be involved in creating a subsidy for shareholders any more than it should be involved in subsidizing something else? Needless to say, most people don't like this idea very much.
The Corporation is a great movie on that. Naomi Klein's, she writes wonderful articles and books on exactly this subject.
So sorry, go on, please.
By pushing out the technology as it arrives and trying to maintain make sure the technology always exists for everybody in a free and accessible way, we are making sure that the technology isn't taken over by any sort of monopolizing entity.
Okay.
And that's a very important thing, because you give somebody the power to do magic, then they will use it badly unless everybody has that ability.
Now that's a very heavy thing to say.
Oh, yeah, I know. I'm vaguely post-hippie.
So notionally, right, what you're talking about here is that if you had a sort of Microsoft of digital fabrication, it would, Microsoft is actually not really a good example because Microsoft still operated in a somewhat competitive environment. But if you go back to, the great trusts of 19th century America, these enormous institutions that just made and broke law and, practically owned the country at some points. So you have this enormous drop in the production costs for a large class of goods, monopolized under patent, and you wind up with this enormous, the stuff company that makes whatever stuff it is that you need using this molecular assembly approach.
Yeah, so you would have a cornucopia corporation.
The company that owns the ability to produce whatever you want at bargain basement prices. Yeah.
You can't compete with a scarcity economy cannot compete with a post-scarcity economy. So scarcity is a very that's one of the core concepts of this. Free software shows us that scarcity need not exist in the digital world. Free hardware and digital fabrication is showing us that it doesn't have to exist in the material world either.
Right. The side effect of digitization is abundance.
And well, actually, abundance already exists. We the entire digital fabrication revolution isn't really changing that. All it's doing is trying to open people's eyes to the option of fixing the distribution routes. That is to say, since the Industrial Revolution, there's been more food produced in the world than people to eat it.
Yes.
And the entire reason why we have the market economy pushing food out of the way at the moment is a result of a big mistake, which is Thomas Malthus wrote this essay in response to William Godwin saying, once the population rises, wages will inevitably go down because there isn't enough natural resources to go around.
Yes.
And, well, he was wrong.
Well, I'm not at all sure about that, actually. The thing is that everybody assumes that there are always going to be jobs. And in fact, when you get these kind of enormous breakthroughs in manufacturing capability, that's not necessarily true. In the same way that when you get this enormous breakthrough in farming capability, the number of people in the farming business goes down to 2% of population or 1% of population. If the same thing's happening in manufacturing, at some point you wind up with an enormous capability to do stuff with not very much human labor, and most of the population has nothing to do.
Yeah, which is not necessarily a bad thing.
Oh,
because
well, depending on how you manage your property rights. Because it's one thing to have nothing to do if you have some kind of equitable division of property, and it's another thing to have nothing to do if the corporation owns the land that you could potentially rent and the soil that you could potentially farm.
And they start saying that, we're giving you food, we're such a nice company, and you don't own anything except for what we give you, but we're really nice for giving it to you because we've always owned it.
Right, dreadful corporate socialism. But I mean, this is a real concern that I have, that we're heading towards a world where, because of all these increases in efficiency, there just isn't an enormous need for labor. And I really worry that the poorest 2 or 3 billion people on the planet, who have not really a great deal of ownership of anything right now and not a huge educational background either, to put it mildly, are going to wind up in a position where all of these systems are created and they're left with no way to get their foot onto the ladder.
Yeah.
And I mean, for me, a lot of the global Swadeshi stuff is about trying to find an option for the poorest, third or half of the human race to say, okay, look, yes, all this amazing stuff is happening, but here's your design for a stove, here's your design for a solar cooker, here's your design for a water purifier, and here's a way of tripling your agricultural output. Stay on your family farm and live like kings.
Mm-hmm.
I mean, so that you keep people on the land and you retain them in the productive role of farming, so they don't get kind of, sidelined and sideswept by history.
Yeah. What's going to be interesting, though, is what happens when you have lots and lots of people who are no longer reliant on the market economy in the current form. I mean, you'll always have some sort of market in this place, but the current form of the raw goods coming from Africa and Asia and being pushed to the West, they're manufactured goods.
So you're talking about sort of fab level self-sufficiency, where you've got a little town with a fab that makes its own shoes and its own transistor radios and its own the rest of this stuff, and a couple of times a year somebody drops off another shipload of goo, and it sort of sits on the docks until they need it.
Yeah,
I mean,
or you manufacture your own goo, or even better, the machines, they just take what they need from their environment.
Yeah,
so,
where you basically shovel all your old stuff into some kind of gigantic hopper and the machines tear it apart to make more goo.
Yeah, because, if you have powerful enough technology, then at the basic level, everything is just bosons and fermions.
I thought you were going to work this from atoms, but always one step further. But I mean, there's something there, right? When you talk about scaling back from the market economy, you're talking about people being increasingly able to manufacture what they themselves need.
Yeah.
So, I mean, I see that primarily at the farming level, where you're talking about people being able to grow more of their own food using things like, biodynamic permaculture kind of concepts. You're talking about them being able to do their own consumer goods, their own medical appliances, their own computers. We've already got somebody making their own, making software. You put all of these pieces together and you begin to have, as you're saying, this much higher level of self-sufficiency and autonomy, where you don't need to go to the market for things.
At the moment, mass manufacturing has nothing to fear from this, because chances are that until we come up with some sort of really good renewable power source that's easy to get, and develop the technology to a very high level, the cost of digitally fabricating, say, a laptop or a cable or a building is going to be much higher than producing it using the old brute force means.
But, I mean, that's something that Martin challenges. I mean, his thing about recreating the tractor is that he can do it for 10 grand rather than 180 grand by the time you take all the tools into account, simply because he gets the design right.
No, yeah.
I mean, I still think there's a possibility here that as you begin to get this kind of boutique manufacture of consumer goods and computers and tools, that what we'll see is this overhaul when the things just jump in efficiency by a factor of 5 or a factor of 10, simply because nobody's really asked these questions for 70 years.
Well, the current, like, the way the economy is currently made, it doesn't really promote efficiency. It promotes efficiency on a company level, that is to say, make the goods in as an efficient way as possible.
Yes.
It doesn't say make the goods themselves as efficient as possible.
Right. So design for obsolescence, difficulty in disassembly at the end for recycling. Yeah. It's like this interlocking series of local minima.
Yeah. So as Martin said, once you have designed something that's supposed to work for your entire life, the entire game changes.
And of course, what we're saying here is that market forces don't have the necessary capability to produce those devices. You can't get a market to produce a device which will last an entire lifetime because it's fundamentally more profitable to produce a series of crappy devices that break after 5 years.
Look at the automotive industry. I mean, you have increasingly crappy cars coming out of the Japanese and Korean car companies that are, more or less designed to last for 5 to 10 years.
Yes.
And after that, just not be worth anything.
I mean, cars are ridiculous. They're just appalling pieces of technology.
But like 70, 80 years ago, you had, Studebakers that just lasted and lasted and lasted. You could do anything to them and they would just work. And basically somewhere down the line, somebody figured out that isn't a very good market model if you want to sell lots and lots of cars.
Yes.
So we kind of need to take greed out of the equation and acknowledge the fact that scarcity hasn't existed for the last 100 years. Yeah.
Yeah, I mean, I saw a very interesting piece on this about how in the 30s and maybe the 20s, there were a series of meetings in America about, how to handle manufacturing surplus. And this idea of, sort of consumer culture was something that was fairly consciously created. I wish I could remember the name on that, but, we'll put a link in. When we post this, I'll find the URL and we'll post a link.
Yeah.
I mean, there's something really fundamental here about the technology that you get being reflecting the process by which it was produced, right? That if you've got a company whose job it is to make money from individuals by selling them stuff, the company doesn't produce what the individual wants, it produces what is most profitable to produce.
Yes.
So we're talking about a misalignment of incentives in the same way that we've got misalignment of incentives at the political level. People do what it will take to get them elected rather than what's good for the voters.
And that's part of the reason why Fablabs are interesting as a personal manufacturing device. Up in the north of Norway, I said there was a lab there.
Yes.
There was this Sami sheep herder who decided that it would be really beneficial if his sheep could tell him if they were in trouble. So that's how the Norwegian Fablab started, actually. They started by making cell phones for sheep.
Oh, that's great. What is a Fablab? It's a place where you can make cell phones for sheep.
Yeah, well, and it was a great project because, you suddenly have the ability to call up a sheep, at any given time, and, it's just this thing that's hanging around its neck.
Sure.
And it contains a GPS device or something, you've got all sorts of instrumentation devices there. You've got a gyro that says whether the sheep is sitting up or lying down, or if it's moving in general.
Wow.
Right?
Wow. So you've got instrumented sheep.
Yeah, and, from that, you can call up the sheep to get its current status, what the temperature around it is, basically if it's doing good, how you doing, And then, what's more, you can have the sheep call you if there's any problem, like if the sheep has been lying on its side for a couple of hours, then it's probably dead, So,
wow. So the instrumentation package figures out that the sheep is not doing too well, like, wow, it's really cold here and it's been cold for a long time, wait a minute, something is wrong. Yeah. And it phones you and says, oi.
Yeah, so, if you think about cell phone companies.
Yes.
Would Nokia ever benefit from building a cell phone for sheep?
Well,
Probably not.
the odds of a cell phone for sheep making it through the corporate process into production is essentially nil.
Yeah,
Right?
exactly.
I mean, it's not even it's whether they should do it; it's whether they can. And the answer is, to all intents and purposes, no, they can't.
Yeah. So it just wouldn't be cost effective for them to develop it. But for sheep herders, it's a brilliant concept, and of course, it should be developed.
Yes,
So
absolutely.
by pushing the entire design and production process downwards, you're getting all sorts of stuff like that.
Right. So you get this kind of, this sort of practical brilliance at the frontline contact where people are actually, right next to their problem. What we really need is a device that does exactly this, and you wind up with a cell phone for sheep.
Yeah.
Or you wind up with, whatever it is they're doing in South Africa, or whatever they're going to do in Jalalabad.
Yeah, and Jalalabad is focusing in a big way on prosthesis. Like making artificial limbs for people who have, had the American Army on them. Sorry, okay.
No, we can't go there. We can't go there. But yes, exactly, right? It's fundamentally the state which gives with one hand and takes with the other. So, regionalizing this capability to come up with the technology you need. Right? What we're talking about here is a sort of breaking down of some kinds of mass culture. On one hand, these Sami sheep herders design cell phones for sheep, and maybe some nomads in Senegal decide that they need exactly the same thing for their cattle.
Yeah, so
and
they
copy the
download
design.
schematics, change them to fit their environment, and good to go.
So on one hand, it's kind of global because it's all of the beast herding people who are exchanging technology for calling their animals. And on the other hand, it's this kind of hyper local thing of like, what do you mean you can call your camel?
Yeah. And somebody actually used the phrase develop locally, emerge globally. And that very neatly encompasses this.
Oh, that's fantastic.
Just by that's it entirely. You develop what you need, where you need it. You push it upstream. If somebody likes it, they will pull it downstream.
Yep. This is exactly what happens with open source software too. It's the same model of you scratch your own itch, and if other people have the same problem, you wind up with a project. Yeah,
which leads to Larry Wall's 3 virtues and all that. But
you better explain those. Not everybody knows them.
Yeah, the 3 virtues of a programmer are laziness, impatience, and hubris. Laziness makes you do something that, because you can't wait for somebody else to do it. Or it also makes you automate some system or, make something automatic. Impatience is, that's probably the one where you don't wait for somebody else to do it. You just go in and do it yourself. And hubris is what makes you push it upstream and say, oh, look, I made this. You should use it.
Yeah, the willingness to work on huge problems too. Oh yeah, web server, I can do that, and boom, 10 years later there's Apache and it's like 80% market share. So, putting all this stuff together, right? This is an enormous terrain. It's an enormous terrain. We've talked about everything from molecular assembly through to, school children in Zimbabwe fabricating digital clothing, but it all comes down at some fundamental level to, tangible machines. I've seen adverts for these things where it's, $1,800 for this box that will produce any fabricated little metal widget that you want. So, this is really, tangible, practical, for real stuff.
Yes.
There's a shopping list of things. You buy one of everything on the list, you put it in a room, you connect it to the mains, you have a Fablab.
Yeah.
If you're off the grid, you run it on a generator or solar. It's unstoppable.
You have frontier level research mixing in with everyday life of everyday people, and you've got this strong weaving connection of interesting things that are emerging from that. it's not every day that you mix rocket scientists in with, your greengrocer.
Right. And
So,
it's a single fabric.
yeah,
Which is kind of what happened with open source too. That you could have the
exactly.
same project and it was, some professor of computer science on one hand and graduate students in the middle and some 14-year-old kid with a knack on the end.
Yeah, you're democratizing innovation, to use Eric von Hippel's term for that. His book is actually it manages to explain how the open source development model actually works in economic terms.
Wow.
And that's a very that's not something that we couldn't have hoped for 10 years ago.
We're going to come back to that one, but we'll be here for 3 hours if we go near there.
Yeah.
So, I want to get back to this thing about the pragmatism of it, right? There's a list of things that you can buy. You put them in a room. You power the map. It's a Fablab.
Yes.
And that list is presumably online, or you can get it by emailing somebody, and there's a procedure for doing it.
It's available online, and it needs updating, but it's available online.
Yeah.
And currently, the Fablab out of the box with the standard configuration is about $70,000.
Okay, so 5 years from now, $25,000. 10 years from now, 500 or 5,000.
Mm-hmm. Yeah.
So, it's the kind of thing that it's rapidly, within a matter of 5 or 10 years, it's going to have come down to hobbyist level.
Yeah.
All these guys who are currently rebuilding engines, in their garage that they share with two buddies, are going to be building their own machine tools.
Exactly.
In only a few years.
Actually, I heard about a great project here in Iceland where two guys decided they wanted a yacht. So they sat down and thought, okay, if we want to build a yacht, then we need tools for it.
Yes.
So they built this big CNC plasma torch and used that to build their yacht.
Whoa. Whoa. So
start off by making your tools, and then you make your product.
Computer-controlled plasma torch to cat yacht is kind of a big deal.
Yeah.
That's getting easier and easier and easier, right? The computer-controlled part is getting easier and easier. The software is getting easier and easier. At the end of the day, you stick your cutter on the tail end of it. One of them is this size and does micron precision, and that's what you make circuit boards on. One of them is 40 feet long, and that's what you make yachts with. And then there's this thing over here that's, based on a rep wrap, but what it works in is concrete, and you print houses with it.
Mm-hmm.
What you're talking about is kind of a single architecture for making things in space.
Oh, yeah. Definitely.
The ability to move a point in space precisely with a cutter or a squirter attached to the end.
Yeah.
Configure it to the materials, configure it to the job.
Mm-hmm.
Download what you need from the internet or design it yourself on your CAD package and throw the entire thing out the door.
Mm-hmm.
And it's actually happening now.
Yeah, it's, the more insane parts of what we've been discussing for the last hour are...
I can't tell which parts those are now.
Well, okay, the most absurd things that we've discussed.
Yes.
The most optimistic people say it's 20 years from now. I'm going to err on the side of caution and say 30 to 40 years, but that's just because I'm used to working with bureaucracies.
Yeah, quite. But even what we have right now is kind of astonishing.
Yes. What's available now is interesting, it's cool, and nobody knows exactly what the limits are yet.
And I still come back to this, that it's $50,000 worth of gear that you order on Amazon. And you put it together and you can fabricate all of this stuff.
I can't order all of it on Amazon.
Well, all right. You know what I'm saying, right? It's not.
Okay.
This isn't some $100 million research thing. This is kind of an off-the-shelf package that you could, theoretically order, and a sea container comes, and you take everything out, put it inside, and boom, there's your lab.
Yeah. I've been ordering this just this week, so I've got it fairly fresh in memory.
Yes.
It's about 22 companies that provide all the basic equipment.
Yes.
And the most expensive thing is a 3 meter by 2 meter by 1.5 meter machine tool called a ShopBot, which does CNC routing in 3 dimensions. And when I was in Norway last year, there was canoes. They're making canoes.
Yes.
So using this device. So that's the biggest device. That's the most expensive bit.
Wow. Wow.
And the low scale is a micron level cutter that you can etch circuit boards. You can make molding and casting stuff by cutting into wax and doing urethane molds from that. So that's the entire that's the spectrum that we're working with.
Wow. So, I mean, all of this stuff has come together in what, the last 5 years, 10 years? How old is the Fablab?
I think it's about 5 years. Yeah, probably 5 years. I'm not familiar with all of the backstory.
I'm sure it's got a history to it. I mean, Martin hinted at this last week with this the second industrial divide book.
Oh yes, I've ordered that, by the way.
Oh, cool. I should get hold of a copy of that too.
Yeah.
So, one way or another, I mean, the little boxes that do the cutting and the welding and the molding and the squirting and the forming will continue to get cheaper. The culture of how to apply this stuff will continue to evolve. The library of things you can make will build up. And I'm certainly, I mean, as soon as you get the Icelandic Fablab sorted out, I'm going to be over there making stoves and solar cookers and all the rest of this stuff. Because it's so much easier if you could just take your piece of sheet steel and have the machine cut it. Even if in the field it'll be done with a little man with an awl, it's nice for us, privileged Westerners to just say, okay, here, laser me off one of these, let's see if this works.
Yeah.
Because it speeds up the R&D.
It does.
At some level, it sounds like it's unstoppable because it's kind of already happened.
Yes, and it's also, it's a bit viral as well, because every time a lab opens up, somebody else comes and says, hey, I want one.
Yes.
Since we started organizing the lab here, there's been 3 different places in Iceland come and say, okay, we want one, when are you going to come and set it up for us?
Wow.
So one of these is a university, so...
Wow. So slowly, the Fablab begins to integrate more and more tools so you can begin to self-replicate the tools which make more Fablabs. When are you going to get one for us come over and we'll teach you how to make one for yourself. Yeah. And pretty soon you have these things working 24 hours a day making more Fablabs.
Yeah, and why not? If it makes sense, and do it.
Well, why not? Because it's insane.
Oh, insanity has never bothered me much.
No, indeed. And I mean, this is the same thing Martin is talking about, right? These networks of tools that can be used to make each other is turning into this thing which is cropping up again and again and again and again.
Yeah.
And, I mean, to me, that seems like it's a really fundamental emergence. I mean, I sort of... It's like we're domesticating technology. In the same way that if you had cows... and you wanted to start a new farm, your cows would replicate, and then you could give copies of your cows to the kid who wanted to go and start the farm. It's kind of like that we're working at this jump where you have a set of technologies, and if somebody would like those technologies, you can make them a copy, and then they can go do it for themselves. It's the process of the technology becoming ambient.
So the information theoretical questions here are, what is the bandwidth of a cow? As in to say, if you want to store an exact description of a cow in a computer, how much space do you need to use if you use loading and compression and that kind of thing?
But I mean,
second, how do you get a cow from the description on the computer into the real world? That is to say, how do you fabricate a living cow?
Well,
probably very hard to do. I don't. Yeah,
that's not quite what I meant. I mean, what I'm talking about.
I know. But,
just causing trouble now.
I'm just adding on more insanity since we've gone down that path anyway.
Well, I mean, how could it go otherwise with us? But
yeah.
I mean, this thing of like, if you have it, you can give it away, right? We first saw this with compilers.
Yes.
Right? You could compile. The compiler could compile its own source code, and that meant that you could modify the compiler in any way that you liked, so you could have evolution of compilers.
Yes. And the entire process applied to anything, we generally call it bootstrapping, right?
Okay, so what you're talking about is bootstrapping a tool chain for machine shops, essentially.
Yeah. Yeah.
So that you have a machine shop that you can use to make another machine shop, and as a result, you can then have an evolution of machine shops because you've got the ability to make another one of those if you want it, only with your own design changes.
Exactly.
Which means that we need some kind of free intellectual property, or well, I should be precise here, right? We need free designs that you can then make into free machines.
Yes. So free hardware is a very important part of this, but free software no less.
Yes. Well, you need the software to make the hardware.
Yeah.
And
exactly.
it's like we've prototyped this idea of free in, I wish we had better terminology, but this free as in speech manufacturing process.
Yeah, free as in freedom.
Yeah, free as in freedom, right? Which we did with software, and now we're in the process of doing with hardware.
Yes.
And, Martin has this big thing that the natural scale for all of these things is, sort of the skilled individual has the ability to make more or less the entire system.
What Martin is doing differently from Fablabs is he is bootstrapping from nothing. He started out with logs and just almost nothing really.
Yes.
We're taking the current apex of modern technology and trying to bootstrap from there.
Mm-hmm.
Our job is probably easier, but I think Martin is going to yield a lot better results in the long run.
Well, it's not clear that these are separate projects, because at the end of the day, like the electronics workbench component of the Fablab is something that Martin is just lifting wholesale because he wants to be able to make motors and, all the boards to control the CNC gear that he wants to make.
Yeah.
So, a tractor that you can make in a Fablab is not an implausible thing. You might need to add a couple of additional tools to it, but if you add the couple of additional tools so that you can cut the 1/4-inch sheet steel, then you can make the tractor, then you can grow your food, then, this line between the open farm tech model and the fab model just kind of fades out.
Yeah.
It's a farm that you can build your own transistor radios on. It's a farm that, if he ever gets this aluminum extraction from clay going, then there's your raw material feed directly into the Fab Lab.
Yeah, I want to figure out how to modernize processes for making cloth out of barks of trees.
Wow.
Which was done a lot in Tahiti, back in the day. I'm not entirely sure what the current status is, but I've been reading a lot about cloth manufacturing recently, and it just seems like something that Fab Labs ought to be able to do.
Yes. Well, cloth was one of the originals, right? This was the whole Swadeshi thing at the beginning, was about making your own cloth.
Oh, yes, of course.
Khadi.
To put it into the propagandian context, we definitely need cloth.
Well, right. It's just that now the spinning wheel is actually a 3-dimensional XY table that lays out your strips of bark.
Yeah.
I really think I should make like a Gandhi-style spinning wheel in the Fab Lab when I get over there.
Oh, yeah.
I think that would be a very elegant thing to do, What is it? Oh, it's a Gandhi model spinning wheel made in a Fab Lab.
Yeah.
It's terrible.
There's no end to the madness that's going to come of this. But,
absolutely.
That's the beauty of it. You take something as powerful as this, you put it into the hands of average people, and magic will happen. One of the things I figured out when I was starting off in the Fablab project is that technology is about people. I keep saying this to everybody. And it's so true. It's so remarkably strong, that entire concept. That, while technology is working for people, with people, then it's doing its best. But once it starts working against people, it isn't succeeding. It isn't doing what technology wants to do.
Beautiful.
So,
well, we were going to try and keep this to half an hour. We've now gone to an hour and a half, but I think it's very good stuff. And thank you so much for doing this, Smari.
All right, well, no problem, and I'm looking forward to next week's